The goal of this section is not really showing you how to code D3. I think there's a lot of resources on how to do that, and I'll share those resources when we get to the end of the presentation. What I more want to give you guys is maybe some of the conceptual stuff with D3. So the idea here is we'll talk about like what D3 is and what it isn't, and I'll show you some examples and try to explain the key concepts, and then the rest of it's really just like syntax, like how do you actually use it. That won't be covered today, but we can maybe cover that in future sessions. So before we talk about what is D3 and what can it really do, there's a few prerequisites. I think all of you are familiar with these things a little bit. You've all kind of played with them, but we'll jump into them. Ken's laughing. Maybe not play with it a lot.
I have been, but I wouldn't say I'm familiar with it now.
Well, I'm going to give you the speed, like the very fast run through of what they are, like very, very basic. And I'm not, like I said, we're not going to jump into code, like in a lot of code today, so it's not super important, but the prerequisites for using D3 for web visualization, at least, is HTML, CSS, and JavaScript. And I also want to talk a little bit about visualization on the web. So HTML, what is HTML? HTML tells you what kind of the structure of a document you have is that you're viewing in your browser. So you basically have some markup language where you can say, I have these different elements. So to use an example for HTML, you could say there's a circle on the page. And it actually might look something like this. This is actually an SVG circle. So it's a circle element, and it has like a radius of 75, and that will appear on your page. So HTML tells you what content is actually on your page, what the structure is. CSS is for styling that content. So CSS, you would take the same circle and say, hey, the circle is red. Syntax might be something like this. Hey, the fill of the circle is a red color. Finally, JavaScript just adds interactivity. So for example, with the same circle, if you want something to happen when you hover it, like a tooltip appears, that's when you would start to use JavaScript. So in this example, I used some JavaScript here to say, like, look at the document and find the circle that I have, and then on the circle, add an event listener for when someone mouse enters that object. Mouse enter means like hovers over it, basically. And then there's some sort of function I can run to say, like, this is what happens when that mouse comes in. So those are the kind of the three core pieces to doing visualization. Again, there's HTML, which has the structure. There's CSS, which visually styles your structure. And then there's JavaScript, which allows you to add the interactivity, like tooltips, brushing, things like that. So really important to understand about HTML is that it's a tree. So trees have nodes. And in this case, it's really like the nodes are elements in your document. So for example, this could be one way to look at an HTML structure. You have the body of the HTML, which is where all the content that you're going to see on the page goes. And you might have a div element in that. That's a container. And within that div element, you might have a navigation element where you put maybe some navigation for your application or your website. Now, as a sibling to that, you might have outside of the div, but next to it, a table. And so that table probably has some elements inside of it, like it has a couple of rows, and those rows have elements inside of it that are a couple of TDs or table cells, right? So it's really important to understand HTML as this tree structure of nodes. So these nodes, also called elements, they can have parents and children, and they can have siblings. So that's a very nested structure. And that's how you construct an HTML document. This is called the document object model. So you'll see the acronym DOM for DOM a lot. So I'll reference that a lot. So when you hear people talk about DOM nodes or DOM elements, they're talking about these individual components. Oh, and here's what it might look like in HTML. So I know you guys have seen a little bit of this, right? So here's the body tag, which is the all-encompassing parent. So it's opened here and it's closed here. And within the parent body, we have two elements. We have a div and a table. So there's the div, there's the table. Within the div, we have the nav, so there's the nav. Within the table, we had a row with some cells in it, another row with some cells in it, right? So this kind of nested structure for building a document. Real quick, just talking about visualization on the web and how it happens. There's really three techniques you can use. There's SVG, which stands for Scalable Vector Graphics. There is Canvas, which is a rasterized type of rendering, and then there's WebGL, which uses kind of the graphics card. We're not going to go into detail on any of these options today except for SVG. and I'll explain why. So SVG has the same hierarchical structure as HTML. It has this kind of tree of nodes. So you have like an SVG node, and in that you can do things like create circle elements and create rectangle elements. And you can nest these things, like you can create group elements and nest that. The nice thing about SVG is it works natively in the browser, and pretty much all browsers post IE 5 or 6 or something like that. So we can use it there. We can use it the same way we use browser elements for the most part, especially with like using JavaScript to interact with it, to add event listeners, etc. Because of that, it's the easiest to use of these three options. So it's the easiest kind of rendering mechanism we have, which is why you see a lot of people use it. It's used by Sketch, so you guys are using Sketch a lot. That's all SVG based, and you've probably seen the export SVG option. Now, if SVG is so great, so easy to use and work natively, then why are these other methods exist? SVG doesn't scale well when you're visualizing lots of data. Like if you want to put 10,000 or 1 million circles on your page, SVG is very bad for that because it's too many elements for the browser to hold in memory and handle and things like that. So really, Canvas and WebGL are solutions that scale better with larger data, which is why people use them. WebGL also has some functions that help with 3D rendering, which we're not going to go into today. So in short, SVG is really good for 2D rendering with not too much data. And really, for most of our visualizations, we don't get close to that point where it's too much data. I mean, you think about a line chart we build, it might have like 100 points in the line chart or something like that. It's not a lot of data really.
Minor problem from the first set does not scale.
This is a good point. Yeah. So I had thought about this and didn't update it. Yeah. So SVG scales well from a sizing perspective. Like if you take an element and blow it up, it'll redraw it at that scale. So therefore, you don't have any kind of artifacts of blowing it up. Where you with Canvas or WebGL, really you would if you were just to take the static picture and zoom in on it, right? Because the pixels would all goes back to DPI and PPI. It's a very complicated topic. Okay, but it doesn't scale well in terms of lots of data. Oh, here's some example of the type of nodes that exist in SVG. So you have rectangles, which draw little rectangles, and they're called rects. There's circles, which draw circles, and the circles, by the way, they don't have to be perfect circles. You can draw ovals and or actually, you can't. They have to be perfect circles. That's incorrect. Lines. What? Arc. I don't think so. I think you use paths to make arcs is how you do that. Lines are just straight lines. They can only be straight. I mean, they can go at any angle, but they're just straight lines. Path is probably the most flexible element, and that's where you can draw any kind of shape. So if you're drawing a triangle, if you're drawing a hexagon, if you're drawing a county, exactly. So paths can be filled or not filled. So there's two kind of properties on most of these elements, which is fill is the color that you draw inside of a shape. Stroke is the outline of the shape. So you could have the top path there has a stroke but no fill. So it just looks like a line, curvy line. The bottom one there is kind of like, to Scott's point, I was meant to be like a zip code or a county overlay. So that's a closed path with a fill color in it. So you can see kind of the shape. So you can use path to draw any kind of line you want, a complicated line, or you can use it to draw shapes, complicated shapes, whatever it might be. It's very flexible. Okay, so that's the prerequisites. Any questions before we jump into what is D3?
I have one question about SVG.
Sure.
With the county example, what if I had drawn a map of, say, Georgia and there were many counties? How would I be able to distinguish between?
So you would have to draw a path for every county. So you couldn't draw one path that covered that entire thing. I mean, you might be able to, but in a real kind of data visualization situation, you would probably add each county would get its own path shape, and they just put on the canvas next to each other to form the Georgia outline. Okay, and they're identifiable by their position? Okay, so HTML elements. They have, sort of the same with SVG nodes, they have attributes you can apply to them. And so there are attributes, they're kind of built-in ones to the browser, like ID. So you can give something an ID, and that is like a unique identifier for it. So in that case, you could have that county having a unique identifier. There are other ones like class, which are used to group elements. Like you might say, oh, all the table rows are of class something, and then I'm going to style everything in that class that way. You can also make up your own attributes. There's some rules around that and some things browsers won't allow, but there are ways to make custom attributes as well on your elements.
What level you need HTML, CSS, and JavaScript?
What level of knowledge do you need to do D3 things? Personally, I kind of picked it up on the way as I went through D3 tutorials. I think just a basic understanding of like the HTML DOM, like the fact that there are elements there, what the elements are, kind of how to add and remove them, that's useful. And then for CSS, knowing how to style those things, specifically knowing how to say like, I want to style a certain class or a certain ID and position things is important. So that, other than that, you don't have to go too deep on the CSS unless you like have a use case for it. Really just being able to say like, I want this class to be a certain thing. And then JavaScript, that's probably the most D3 part that you kind of got to learn. The basic syntax is good, so knowing how to write functions is important. Knowing how to use object syntax, like what a JavaScript object, like what JavaScript object notation looks like, and how to write that. That would be important as well. Does that help? Okay. So what is D3? Stands for data-driven documents. It's just a JavaScript library for working with data visualization on the web. So it's JavaScript. You can load it anywhere that can support JavaScript and use it. And it does data things. What I mean by that is it doesn't create charts. This is sometimes a point of confusion for people outside of the D3 world that have seen the outputs. They say, oh, I want just like the D3 bar chart. There is no D3 bar chart. There's no call in D3 to make a bar chart even. But it gives you all the tools you need to create charts. These tools, you can kind of break them out into two types of things. Some D3 functions have nothing to do with rendering. So you don't even have to use D3 necessarily for data visualization. You can use it for all kinds of things because it has a lot of functions related to working with data, some of which are useful for rendering and some of which may not be. So I just picked out a couple examples. They have random number generators in D3. So if you needed to generate a sequence of random numbers based on some distribution, in fact, I'll show you guys real quick where you can find this information. If you go to the D3 GitHub, there is a API markdown. If you click that, it has a breakdown of like the entire D3 API. So to show you like these are the different kind of things you can use. So I didn't even know there was a random number generator actually until I was putting together this presentation and reading this list, and I saw random numbers. And you can click on this to get to the documentation for that, and you can see there's like functions for creating uniform, like randomly distributed numbers in a uniform distribution versus a normal distribution versus exponential, etc. So you could use it to create like kind of mock data if you needed, if you wanted to. You have scales. So scales, we'll talk about in a minute in an example, but essentially a scale takes one type of value and produces another type of value. This becomes very important for visualization, but it could be used for other things as well. Interpolators. So interpolation is figuring out how do you translate between two values. So scales use interpolators to figure out, for example, an example of interpolation. Let's say I have the color red and the color green, and I ask you to give me the color that's the halfway point between red and green. How would you do that? You would need some sort of algorithm for interpolation. D3 comes with a bunch of them, and it has a bunch of different, not only just from, it has numeric interpolators, but also has color space interpolators that use properties of colors to figure out, how you would do that. Data set transformations, that has a lot of functions for taking a data set and changing it, which becomes very important in visualization. A lot of the time you'll get data sets in a very flat format where you have like just records, but visualization is very hierarchical. I'm not going to talk about that today, but we should talk about it on a future call. And D3, that's an example where you use D3 a lot to basically take a flat data structure and make it into a tree structure that better maps to how you would set up the DOM, for example, that tree we looked at. Let's just talk about an example function for this, a scale. So like I said, scales basically take a value in, they do some sort of transformation and produce a value out. So maybe your input value is 3, you run it through a scale that you set up, and the output value ends up being 6. There's all kinds of scales. There's linear scales, there's exponential scales, which are all numeric transformations. There's kind of color scaling that you can do. You can also do, scales don't have to be numeric. You could use scales as a mapping between two sets of discrete values potentially. Like, hey, I have 5 names coming in on one side, and I want 5 numbers coming out on the other, and I want to do this kind of mapping between them. We'll talk about that more in an example. So I'll give you a more concrete example of the scales. Let's say that I'm designing for an iPhone X, and after a great presentation from Gan about PPI and DPI and points, I realized I need to convert all my units from points to pixels. So how can I easily do that conversion? On the right is my kind of information about the differences between the two. So maybe I want to just map the width of each one. So I create my scale. And this is the actual D3 syntax. So don't feel like you need to follow along with the syntax necessarily. I'll walk you guys through it. This is the kind of stuff you can just look up when you're actually doing implementations. But you'd call, hey, I want a linear scale from D3, and the domain of a scale is the kind of expected input range of inputs. In this case, I'm going to say, okay, I know my scale is going to go from 0 points to 375 points, and then range is the output you want to map to. So if we're at 0 points, I want to map that to 0 pixels. If we're at 375 points, I want to map that to 1125 pixels. And now my scale function can take any number and do the mapping for me. So if I put in 40 points, it gives me 120 pixels. There's a lot of other cool features of D3 scales that are useful for, so this is like useful outside of even visualization. You could use this for any kind of data transformation. But there are also scales that are specific to more easily creating visualizations, like for bar charts. Oftentimes when we create bar charts, we want to create like buckets of space with spaces between them, like margins between the bars, and maybe you want padding between the bars and padding on the outside. And so there are D3 scales that can handle all that kind of logic for you. So you can just say, like, I want to put these 5 people in a bar chart, and I want this much padding between all the bars, and it'll generate the scale that'll give you those positions. So there's a lot of useful features of the scales there. So these are the functions, or examples of functions that have nothing to do with the actual visualization. You use them to produce visualization at some point, but they can be used just out of that context. That's important to understand, is that D3, at the end of the day, is kind of a data toolkit, not necessarily just a visualization thing. However, there are functions that are all about the rendering, and this is, I think, what really gives D3 its power in terms of web visualization. So a couple examples of that, axes generators. So building an axis, you can think of an axis in terms of its core elements, right? If we go back to that SVG model. So an axis is going to have, let's say you have an axis with some labels and some tick marks and a line, like the bar, like the span of it. So you need a line element for the span. You need several line elements for every single tick on the axis. You need a text element for every single tick on there. And you need to like calculate what that axis is going to look like and how many ticks do you want and all this stuff like that. So it's actually a pretty hard thing to do. So it's one of the few things that D3 like auto generates for you if you want that. It has an axis generator. So you can give it a scale and say like, hey, that linear scale I had, I want an axis for it, and point it at the DOM, and it'll generate it for you. And it has cool parameters, like you can say, I want this many ticks, or I want the ticks to be formatted this way, etc. And it'll do all that for you. So it makes creating a scale like a couple lines of code, as opposed to like you having to manually figure out how to create all these things. Interactions, it does a lot there's a lot of library or tools in it for helping with doing interactions you might want to do in visualization, like being able to drag things, doing brushing and kind of calculating how you do that, or doing zooming in and out of a visualization. And then selections. Selections are the secret sauce of D3. It's really, when you're talking about D3 and using it with SVG, selections is what makes the whole thing work. It's kind of the magic. So we're going to go deep on it because it's a really important concept to understand. So selections basically bridge the gap between your data and your DOM tree. So on the left, we have some random data set with a few numbers generated using D3 random number generator. On the right is like the example DOM tree I showed before. If you think about what data visualization is, it's taking some data and creating a visual representation of elements in that data set, right? In the web world, the way we do that is we typically want to create some sort of like DOM element, some node corresponding with data. So for example, in this data set, I might want to create a table cell for every one of these numbers. Selections are what bridges that gap. Selections is what allows you to say, hey, I have this data over here, and I want to create nodes over in the browser that map to that data. there's two things you really get out of that. The first, like I just called out, is that you want DOM nodes for each piece of data. So if I have, let's say I have this data of apples, oranges, and bananas, and I want to create a list of those items in the DOM. I want to have a list item for every one of those. There's 3 data elements here, so I want 3 list items here. I have some sample code you guys can take a look at online that shows these examples. Once again, I'll kind of walk you through it for now. So here's some JavaScript, and what I do is I select the body of my page, so that DOM parent element. I have my data set here, apples, oranges, and bananas, and I use D3 to make a selection. I say go to the body and select all of the list item elements, and then bind it to my data. So this is called data binding. This is the part that tells D3, like, for these things I selected, I want them to be joined together with this data set. What I can say is, don't worry about .enter for now. We're going to come back to this. But what I'm going to say is, when these new data values come in, I want you to create a list item in the DOM for that data element. And then from there, I can manipulate aspects of that. So I can say, hey, just put some text here. I just put a placeholder for now. We're going to, in the next example, we'll make this more data-driven. That gives me these 3 guys become these 3 list items. And you can see I can just like update this right here. Like I can add grapes, and now there's 4 of them, or I could delete like that and get down to 2 of them. See, so D3 is taking the data and mapping it to the DOM and having them kind of update and sync with each other. So that's the first thing we want to do, is just create some sort of DOM node or SVG node for each piece of data that we have. But we also want our nodes to have attributes that are based on the data, right? So we don't want to just put blank list items. In this case, we want to put like the names of the data points inside there. So that's the other thing that D3 gives you, is that it gives you a syntax for changing attributes of the things you're creating based on the underlying data that was joined with it. So if you look at this example, again, same from before. I get the body of the page. I have this data set of apples, oranges, and bananas. I create my selection. I say get all the list items and join it with this data set up here. And when you have data points coming in, create the list items. But now when I start to modify the list items, like when I say set the text of it, instead of putting a placeholder like I had before, like a static value, I can actually put in a function. And this function is called the data accessor. And what it does is it says, run this function against the data for this element to figure out what this value should be. So in our case, the data is apples, oranges, and bananas. So when it looks at the first record, which was corresponding with the data for apples, it'll say the text should be just whatever the data was. So it returns apples. When the second one comes in, it says the text should be whatever the data was for this element. The data is oranges, so it passes back oranges, bananas, etc. This is how you get apples, oranges, and bananas here. And you can see as I update these things, we'll just see the changes here on the other side. So now we have data-driven DOM manipulation, essentially. This is a very arbitrary example, right? I'm just like taking the data and like mapping it back to like the same value. But when you have more complex data structures, which I'll show later, you'll see you can use this function to do a lot of different things. Like we can do a simple example here. Like maybe I want this to always be uppercase, so I could do something like a JavaScript function like that to make them all uppercase. So this function has a lot of flexibility in terms of how you take the data and manipulate it to render it. Giving you one more example, I could do something like change the style of this, and maybe I want the apples just to be red, and so I'll say style the color of this element and do it based on data. And what I'll say is if the data is equal to apples, return red, and it makes it red. So you can do all kinds of data-driven manipulation like this, and this is what gets us to that data visualization. We're going to start talking about how do I size circles and other things based on these attributes of the data, writing these JavaScript functions.
First, I have 2 questions.
Sure.
First, one. What is a function exactly?
Sure. A function in JavaScript takes in a value and returns something else.
Okay.
So you could have like function sum, like A and B, and that returns A plus B, like something like that.
And second question, in the examples where you have a function and it looks like you're passing in D,
yes,
and then it's returning D,
What's the significance, if any, of the letter D?
Good question. There is none that can be, so this is what's called an anonymous function. An anonymous function means that, and that doesn't really affect the parameters at all, but we'll get to that. Anonymous function is basically like you're giving this texting instructions on like run this function whenever it's being called by D3, and D3 calls this function for each element. D3 automatically puts into the function when it calls it the data as the first parameter. You can name it whatever you want to. You could call it E like this, and then this would be E.toUpperCase. This is just first argument that D3 is gonna call. You'll almost always see it referenced as D and D3 examples because it's just a reminder to developers like, oh, this represents data. So D is the common kind of way to do that, but it doesn't really mean anything. It's just it's nice, like makes it more legible, your code legible to do it that way.
So the name of it is arbitrary being
yes,
but the position of it, like A was in this one.
The position is not arbitrary because there's a second argument that goes into these functions, which is I. And I is the index of the value coming in. So apples is the first element, oranges is the second, etc. Sometimes you might not care about what the actual data element is, but you might care about its position. For example, what if I want to make every other row red instead of just like the one that's apples? I could say if instead of using D, I could use I. So I is the position. Just to show you that, if I put I equals 0, I get apples, I equals 1 equals oranges, etc. It uses a zero-based index in JavaScript, so 0 is the first element, 1 is the second. But I could do something like, hey, if, So that percent sign is the modulus function, which allows you to say, like, what's the remainder of dividing two numbers? And so an easy way to check if a number is even or odd is to say, I modulus 2, and if that equals 0, that means that it's not even, or it is even, excuse me. So you can see all the even ones are colored red, or if I want to do the odd ones, I could say, like, doesn't equal 0, and I get the opposite.
Small point, but you also switched between double equal and triple equal.
Oh, did I? That's, okay, so you want to use triple equals. JavaScript has some weird equality things about it. That's outside of today's purview. But
hey, I didn't know if they would pick that. You in the course of doing what you did, you switched between this.
Yeah. In fact, this should probably be $sign equals or something. But
okay.
Cool. Yeah, no, this is good stuff. Any other questions from you guys before we go on to the next example? Cool. Let's make an actual viz now that we have these kind of two premises, and let's just review them one more time, right? All right, so we want to create SVG nodes or some other kind of DOM node based on the data. We want the data to correspond with like we usually want an element per data record, if you will, and we want to like use some functions to say like, hey, these attributes are going to be data driven. They're going to be based on the data coming in. So we're going to make an actual viz, or I'm just going to show you the code and I'll walk you through it. What I've done is I've taken a visualization of the team or some data about the team. I just like went through the team, and since 2016, I counted like the distinct number of projects that people have built on. It's a simple measurement. So obviously Gen's been around this whole time, so he's got a lot of projects, 41. Jesse just joined us recently, so she has 5 distinct projects she's built to. And Lisa and Manazi are basically even because they started like a couple weeks apart from each other. So this is the data set, and what I want to do is I've kind of translated that data set into circles. So here's Gen's circle and its size based on the number of projects he did. Here's Jesse's circle. Here's Lisa, and here's Manazi. So a very simple, sort of like a strip plot almost, but not necessarily. It's more like a grid chart, one-dimensional grid chart, where the circles are sized by this data. So how do we do that? Well, the first thing is we had the data set in D3. Here's the structure of it. I mentioned JavaScript objects before. These are objects, and so each record is a single object, and it has a name and a number of projects. So we have Gen, 41 projects, Jesse, 5 projects, etc. Now, we talked about scales before. One thing I want to do is I want to translate the number of projects into some sort of visual attribute on my screen. Specifically, I want to turn it into the radius of the circles. So 41 somehow needs to become a radius of X in my thing. 5 needs to become a radius of Y in my project. I don't want to just use the actual numbers. I want to like pick how big I want the circles first, and then whatever data comes in here, I want it to conform. Like if if I change this, all these numbers to like 21 or whatever, or just like change the whole scale of them, it should still use a similar kind of output range. So this is where D3 scales come in handy, right? Scales take one set of numbers or one set of data and output another set of data. So I want to translate the number of projects the team has done into radius pixels on my screen for my circles. So I do that using a radius scale, very similar to the linear scale we saw before, but we use a square root scale. Any ideas why we use a square root scale instead of a linear scale here?
Pi r squared, pi r round.
Yes. Exactly. So when doing visualization of circles, you want the areas to match, not the radii, right? Because a circle with a radius of 2 is not twice as big as a circle of radius 1. It's actually 4 times as big because of pi r squared. So we use a square root scale to handle that. Here's the domain of values. I just hard-coded it for now, which I said, okay, I want to use the smallest value will be Jesse's, which is the 5. The largest value will be Gen's, which is 41. And then I created an arbitrary kind of output here. I said I want the smallest circle to be 3 pixels and the biggest one to be 15. So I can update this. Like if I wanted my visualization to be from 3 to 25, I can do that. You see the scale updates automatically. Or if I wanted to change the range of the data coming in, I could do things like that. So once again, this is like the expected input values, like the range of the input data. And this is like what I want to map it to on the other side. So now I can call R scale of 5 and I'll get back 3. Call R scale of 41 and I get 15. Or call R scale of some value anywhere between that and it'll return me the right value.
What happens when you say the domain is 5 to say 20, but in your actual data, the range is like 41?
It will interpolate for you. Certain scales will. So linear scales, scale square root, well, they'll all kind of do the interpolation outside of the range for you. There are other scales where that won't work, and you'll either get like an undefined value back, or certain scales you can like tell it what to do when it gets a weird value. But in this one, as you saw, like even though I took it outside of the range, it still figured it out. But you see the circles are much bigger than 15 now because it just like it said, okay, if 21 is 15 and 5 is 3, then 41 must be some other number bigger than 15, and it figured that out for us. So then the rest of it's just really drawing it. So we create an SVG, so we get the body of the page and we add an SVG element to it, and then we create our circles. This is pretty much the whole thing. So we say, take the circle and create a selection. What we're going to select are the circle elements. And I'm going to bind those circle elements to my data set that I have. And I'm going to say when that data comes in, for each data point, add a circle to the page. This creates the 4 circles for each of you guys. But it's just going to create it without any kind of initial properties. And so this is where I start to style the circle. So you can set attributes in D3 using this attribute syntax. And you can either set an attribute by name with a static value, or you can set it by name and do the data callback to use the data to add the value. So I say, okay, I want the circle Y position. I make it a static value of 50, so that all these circles are positioned 50 pixels from the top of the screen in a straight line, right? Everyone has the same Y position of 50. It's really the X position that I want to modify to just kind of spread the data out, or the circles out. So what I've done here is I've actually used that index like we saw before, and I've said, okay, take the data and the index of each data, and just return the index plus 1 times 50. The reason I did that is because I wanted the first one to be at 50. So when Gen comes in, he's the first record, it's 0. So 0 plus 1 is times 50 is 50. So you get 50. Then when Jessie comes in, she's number 1. So 1 plus 1 equals 2. 2 times 50 is 100, etc. And so each person gets spaced out by 50 pixels. And then for the radius, I'm going to base it on the data. So I say, hey, take the data coming in and take our R scale and calculate the R scale output for each person's projects. So the projects associated with that data. And then I just kind of give everyone the same blue color. And that's pretty much it. That's how you get this visualization. Any questions there?
Yeah, when you do SVG.select all circles, there are no circles in your SVG.
Yeah. Very good question. That's going to come up. That's the next. That's the next topic. That's where the .enter comes in, and so I'm going to cover this next. I think.
So the sequence of the things that you have there with separated by dots is important.
Yes,
Or-
yes, it is.
or
It's
what
very
degree
important,
is
yes.
it important? Okay.
Yes. So some people format their D3 code to kind of like show, like sometimes you'll see people do stuff like this to show like, it won't indent for me, but like putting the attributes after the append, or like maybe not doing it this way or something like that. But essentially, the sequence of events that are important, you need to, first of all, create a selection using select all. So select all will try to select the elements in the DOM. Then you do the data binding to that selection. You say, once I've made this selection, bind to this data set. Then this is Manazi's question, which we're going to answer next, which is you tell it which part of that data you want to work with. .enter is dealing with new data. We're going to talk about that next, so don't worry if you're confused. Then you say, okay, I want to append this element, and then you can style the attributes of it. This order is absolutely important. So it's selecting the DOM, bind the data, append things for the new stuff, do something for those things, style them somehow. Okay, so let's go deeper. This was Manazi's question, sort of, roundabout. What was that enter thing, specifically this problem? Well, actually, you call it the inverse of this question, which was, wait, there were no circles already on the page. Similarly, in our apples, oranges, bananas example, there were no list items on the page either when we did the selection. So how does that work? What happens when you do have elements? What happens when you don't have elements? So this is your selection call, right? So you say body.selectAll list items, and it looks for all the list items in the body when you do that. Then you say bind it to this data set. What is actually happening, well, let's take a pause there. In interactive visualization, we usually update visualizations rather than draw on a blank canvas. So sometimes you'll have no data, like no circles, and you'll draw circles. Sometimes you'll have existing circles and you want to update them. Sometimes your data might drop out and you need to remove circles or whatever it might be from your viz. So let's think about how the data set could change first, and then we'll answer Manazi's question. This is a question for you guys. So here's the data set, apples, oranges, and bananas. In what ways could we change this data set? So this is the strings themselves, that's one of them, right? So we could change the value of a certain record. That's one of them. What else could we do to change this data set? Yes, you could remove an element, exactly. All right, there's one more important one. What other way can we change the data set? Exactly, add a new one. All right, so that's the three ways we really think about data sets that change, is that we either add a value into it, so we could add grapes to the data set. We could remove a value from it, maybe bananas drops out, or we could update a value in the data set, like maybe apples becomes pears, right? This kind of thing can happen when you're like filtering your data, like if you're building an interactive visualization, maybe someone's doing some other manipulation, like changing a parameter that should update the data.
What about sorting?
Yeah, does the rank not matter?
Sorting matters. You can do sorting too, but these are the main ones in terms of how the next part we're going to talk about. Yeah, sorting is absolutely a thing that does matter. In D3 terms, we refer to this as entering, exiting, and updating. So when data comes in, that's referred to as entering. This data record that did not exist before has entered the scene, or the data set. Data that is leaving is called exiting data. So there was this data that existed before bananas, and now it's gone. And then data is updating is like, hey, this record was already there, but we just kind of like changed the value of it. So enter, exiting, updating.
Which is really kind of what sorting is. Like
Yes, sort of, yeah.
I mean, in the sense that what's really probably important here is not that there specifically are pears, oranges, and bananas, but there's a first thing, a second thing, and a third thing.
True. However, you can tell D3, you can give D3 a way to key it as well. So D3 automatically, or by default, uses the index like you said. So it says like, oh, record 0, record 1, record 2. However, when you do your data binding, it's outside the scope of today, but you can give it a function to say like, oh, and key it by this. So apples is always apples, so that it doesn't use the index to figure out what dropped out, or what is exiting versus updating versus entering. It uses the key to figure it out. And that's important for certain types of visualizations you might build. And by the way, all these can happen at once, right? Like you could click a filter and you could have like apples changes to pears, bananas gets dropped, grapes comes in, or something like that. So all these things can happen simultaneously from one change in data set to another. Okay, so let's go back to the question. Wait, there were no circles before. How did we get circles then? What did we actually select? When you bind data to the DOM, D3 keeps track of what changed. So what what it does is when you say select all list item, it tries to find all the list items and see what data they have bound to them already. Then when you join new data into them with this my data set, it does a comparison between the two. And what it says is, hey, do we have any data that was already existed? Do we have any data that already existed here, like some existing list items that corresponded with the data coming in here? If so, then those are getting updated, right? We don't need to recreate the list item for that. It already exists, but maybe it needs to change somehow. Okay, what if I have some data in here coming in and there's no list item corresponding with it in the set? And that's considered new, and that means we need to add it to the DOM. That's the enter. And finally, what data is gone and needs to be removed from the data set? So maybe I have a list item here for oranges, but the data set doesn't have oranges. Okay, that needs to be removed from the DOM. The D3 keeps track of that. So basically it compares what did you select versus what did you try to join in the data set, and it breaks it into 3 categories. This is the stuff that is already existing and just needs to be updated. This is stuff that doesn't exist and therefore needs to be added. This is stuff that does exist, but in the data it's gone, so we need to remove it from the DOM. So to your question before about there were no circles before, D3 saw that, and then we used the enter syntax to say, hey, take this new stuff that you can't find in the DOM and add circles for it. Oops, sorry, something up here with my. Oh, and the syntax is something like this. So you could break it out into multiple steps. Like here's my selection, select all, find the data. To get the things that are new that are coming in, you could say .enter. To take the things that need to leave, you could say .exit. And then the selection itself will just like already have the things in it that exist. You don't have to say like .update or anything like that. Like those are the things that exist already, are stored here.
Another question, like you're writing D3 code, are you importing something?
Yes, you can load the D3 library onto like a web page you're using. That's like the simplest way to get started using it. Just like a script tag in the head of your page. And there's like CDNs, which like if you just type in like CDN D3, you can get the link for it and just like copy and paste that. In JSBin, which I'm using here, just like put some examples together, you can click add library and actually like type D3 and it'll automatically do that for you. If you're doing a more professional web development project, you would actually like use some other mechanisms for importing your packages, but for starting out, I wouldn't worry about that. So going back to the example, in our kind of apples, oranges, bananas example, we knew that the DOM was empty, so we just used enter. Because like we knew we were starting with an empty body, and so we didn't need to update or exit anything. We're just going to do a one-time data pull. We just said select all the list items. There were none that really existed. We said, okay, bind that to the data set. Take what's entering. It's going to be everything because there were no list items already. And append that list item and give it that text. And that's how we got to here. And the same with the circles. So really the magic there was that .enter is how we handled the fact that there were no circles or list items, and then said add them for this data. Now, in reality, we can manipulate this and actually do different things for exits and updates, which becomes important for things like animation, things like that, like animating between states. So what I could have said is, let's say that I have this example above, and I want to update it with bananas gone. So I just feed it apples and oranges as the data set with no bananas in it. So I say body.select all list item. It selects all 3 of these guys first, and it keeps track of what data it had for those 3 guys. Then it says, okay, join it with this data, apples and oranges. When it does that join, it recognizes that like, hey, we had bananas as a list item, but it's not in my data set anymore. So it becomes part of the exit selection. So I say .exit, that gives me all the elements that need to be removed. In this case, I don't remove them. Just as an example to show you guys what you could do, you could say like, let me style them a certain way. Like, let me make the ones that need to leave red, and then bananas will end up being red. They'll still be in the DOM though, because we didn't actively remove it. So when you want to exit things this way, you actually need to say like, you know, remove it from the web page.
How did you know that it was a banana?
Oh, so you just assume that like I recalled this function without bananas. So like, yeah, just assume someone like filtered it out or something like that. That would be like a way to do that. So let's do this in practice. I'm going to use another example from the team, and what we're going to do is we're going to visualize enter, exit, update with data over time. So before we had the static data about like here's how many projects you've done, what I've done now is looked at data. I'll show you, we'll walk through the code. I've taken data about like every month and done cumulative counts of like how many projects you've worked on. So what this allows us to do is think about how the data changes over time, but also entering and exiting, because over time people join the team, and if you go backwards in time, then people leave the team, right? Because if you go in reverse order, you'll find that. So at the beginning, and what I've done as part of the visualization, just to give you guys some background, when I change this this lever, it'll update the data for that date, and you'll see the visualization update. Anything in orange means that it has just entered the scene, the entering collection. Anything blue means that it's been in the data set and it's just updating in the DOM. And then you'll see the things that get removed, they'll turn red and leave the DOM. So we start with, again, this is the very initialization of the project, of the visualization. There was no data. We added the first piece of data for Gen. So Gen comes up here, and he's orange because he's entered. If I go to the next month, you'll see Gen is blue now because he's just getting updated. You see his circle got a little bit bigger. It gets bigger. We'll jump ahead just so you can see a more drastic change. It gets bigger. Now we go to Manazvi and Lisa joining the team. So I click 07, and Manazvi and Lisa entered the scene, right? They were not part of the data set before, but we added them as data. So they're orange because they just entered. We'll go to the next date. What you'll see is they'll turn blue for updating, but they'll also change positions. And so I showed that. What I did for this visualization is I just like put them in order of number of projects, distinct projects. And I did that so you can see that the updating clearly, like you can do all kinds of cool animations with like how to, like in a bar chart, how do the bars resort and things like that to help show the differences, which is important for cognition when you're doing filtering. It's much easier to like see that this change happened versus like just pull it up and the labels are different, but there was no like transition between the states. So we'll keep going, and Manazvi and Lisa just keep working on projects, and so does Gen. This happens for a while, and eventually if we go far enough, we'll get to, I think Jessie comes in right. There's Jessie, so she joins the team, and she did some projects right off the bat, build a couple things, which is good, and then that's updating, right? Now, that we've done entering and updating, what we haven't done is exiting. So if we go backwards in time, we can see exiting. Tara's not in this data set because she never built anything, so she never entered. So there was no opportunity to use her as an exiting member. But if we go in reverse, Jessie's getting smaller and smaller in time, and then we'll see her drop out of the data set because she wasn't on the team in that period of time. We can jump back to when Lisa and Manazvi joined. We can see that resort back to the previous state, and we can see Lisa and Manazvi drop out from the team because they weren't on the team at that point in time. And again, becomes the sole person that lives in the entire visualization from start to finish. So that's a visual representation, kind of enter, exit, update. I'll show you a bit of the code. This code is definitely a lot more complicated just to get a lot of these things working, but I'll try to call out the kind of key pieces. We have a couple minutes left, so I'm going to go pretty quickly. I'll call it a couple functions I use just so you get a sense of what does a D3 project maybe look like. The data set was very flat. It just had the person, the month, and the distinct count of projects kind of accumulating over time. But I really wanted to organize this data set by month because I want to show 1 month at a time. So this is where some of D3's data transformations come in. If you look at the API, there is some section that's referencing transformations. And I used a specific one called d3.nest. Maybe it's not listed as a transformation. d3.nest, which takes a flat structure and makes it into a hierarchy. So I use that to get the data organized by month. I create some selection boxes. I create my canvas. I create a radius scale. In this case, I wanted to make it dynamic, so I didn't hard code the domain. I used some D3 functions to figure out what's the min and max count of projects in the entire data set. So that gives me the domain for my radius scale, and I just map this between 3 and 20. I could change this to like 40, and you could see it. 40, and you see much bigger circle, or like, sorry guys, I keep hitting the wrong buttons on my computer. Make it like 100, and you'll see a much bigger circle. X scale, instead of using the index like last time, I used a special kind of scale called a point scale and gave it a range between 50 and 200, and that scale is used later to figure out like where you guys belong in the visualization from an like x-axis perspective. When you go to the draw code, there's some stuff around sorting to sort the nodes based on like number of projects. But ultimately, the rest of the visualization is mostly what you've seen already with a couple added things. To do the animations, we create what's called a transition. The transition has like a duration. You can also do things like say what kind of transition, like do you want it to animate linearly through time, or do you want to do some sort of like bounce in, bounce out type of operations? In this case, I think the default is ease in, ease out, which gives it a more natural look to it. All right, here's the main stuff, enter, exit, update. So we get our first selection. This is basically my update call. Well, not necessarily. So I take all circles that are existing, I bind the data to them, and I just give them all initially a fill of steel blue, the stuff that already exists. Here's my exit code. I say on exit, turn the circles red, and then over the course of that transition, that 750 milliseconds, animate them to this 200 position, so animate them down out of the frame, and then just remove them. So that's what gives you this whole, we go back and forth between these two. That's how we get that. They turn red, then over the course of 250 milliseconds, they go down, and then they fall out. For the ones that enter, I start them at the same center point, and I just fill them with the color orange. And then for the update code, I want the kind of enter and the existing circles to do the same thing, which is I want them to position themselves XYs based on this X scale and change the radius based on this R scale. That's why you see these points kind of animated into place, and you see them kind of resort over time based on the changes in the X scale, etc. And then the text does the same thing. So that's basically the enter, exit, update pattern in practice. I want to show that to you guys so you understand it. I would not expect you to use it up front. So when you're starting out with D3, I think doing this whole thing is totally acceptable. And this is kind of what I did and what most people do for a while, which is instead of worrying about what's entering, exiting, and updating, technically what you can do is every time you need to redraw your visualization, you can first delete everything inside your DOM, like delete all your circles, and then everything becomes entering because there were no circles there. So it's kind of a shortcut to only use enter all the time. It makes it a lot easier to write the code. You won't be able to do animations and things like that. But as a beginner, that's like the way to do it. And that's what you'll see a lot of examples do it that way, where they just like say, okay, let's just do the enter and not worry about exiting and updating. We'll just reset the DOM every time.
If you go to your code, there's a couple of clarifying questions that I have. Other people may have the same question. Maybe it's just all right here. So if you scroll up a little bit, so at the beginning you said circles, a variable called circles is equal to SVG.
Yeah.
And you did some stuff, and then you did a semicolon.
Yes.
Then you did circles, and you did some more stuff, and then you created another variable, circle entry. How much of that is kind of arbitrary in style, and how much of that's like you have to learn that you have to do it that way in that order?
Good question.
For me, because so far you're not using circles enter or circles update anymore. It's a little bit arbitrary. You could have strung all of that together into one big thing that returns circles that has all of those different capabilities.
Not true.
Okay.
As soon as you call circles.exit, that's it. Like you have the exit selection, you can't get back to the parent selection. So this has to be by itself for sure.
So there's parts of it that are not arbitrary.
Same with circles.enter. Yeah, as soon as you call .enter.exit, you're looking at that subset of the selection. You're not looking at the parent data, and you can't get back to it. I didn't need to name circles update here because I don't use it anywhere else. So this is kind of arbitrary as well. But I did need to name circles enter, and this is why. This is more of a design pattern, like when working with D3, which is that I want my there's some attributes that my entering elements and my updating elements are going to share. And there's some that they're not. They don't share fill color. That's why when I first make the selection, I call fill color up here. Because I say, before you add anything new to this, take the existing stuff and make sure that it's blue. Because I want to make sure people know that it was already existing. Whereas if you look at when I do circles enter, I say make sure these new ones coming in are orange. So I did that in that order on purpose. Before I appended circles. If I called this after this, it might not have worked like that. Secondly, that's the differing properties. Now, they have shared properties. Like they both need to position their X position based on the data. They both need to change their radius based on the data. So in this case, I do what's called a merge in D3, which is I say take the entering circles and merge it with the already existing circles, and then apply all these same properties to both of them. So there is a kind of rhyme and reason to this order here. Again, this is why doing just the enter makes it way easier, because you don't have to worry about any of this kind of order and things like that, which is why it's just that route up front. Yeah, absolutely. Okay, so wrapping up, we didn't really talk at all about like how do you actually make stuff, and that I didn't want to do that because there's a lot of resources around that, and I can help you guys with that. But I wanted you to get a view of like the fundamentals of D3, you know, like what does it actually do? And the really important thing about it does is having these functions working with data like scaling and interpolation and random number generators, but also the binding the data to the DOM. That's like the value added of it. In terms of using all that stuff, now you need to know the syntax and like, okay, how do you create an axis and how do you really make a bar chart and things like that. These are really good resources that I like. D3 came out with a version 4 last year. Yeah, or maybe 2 years ago. It's very similar to version 3. They just like changed some of the syntax. Unfortunately, most of the material online is version 3. That's not a, yeah, you probably have come across that. It's not a problem to use that material still, but you'll have to like cross-reference it with the version 4 documentation to figure out the syntax. Like for example, in version 3, it's called d3.scale.linear. Version 4 is just called d3.scale.linear. So there's small details like that. I listed the version 4 resources up front, so you can start there if you want to. This is a free book. This is actually the book that I used to get up and running with D3, the previous version of it, which was version 4. You can get the download for free, and it walks you through, like, what is D3? What do you do to get started? Kind of some of the topics we talked about today, but in way more depth. How to build a simple graph. How do you add an axis? How do you add a title? How do you create a line chart? How do you smooth things, etc. Really awesome resource. So I highly recommend this one if you want to go further. There's also this D3.js version 4 essentials blog you can check out, which is pretty good. And then these D3 version 3 tutorials are classics, like the Let's Make a Bar Chart. Now they're making a bar chart one. And then finally, there's a holy grail of tutorials on the D3 wiki here that has all kinds of things you can look at. And I find this useful when I'm looking for a specific topic, kind of searching here. Last but not least, examples. There's like so many examples. So if you go to d3js.org and go to the gallery, like probably 75% of the time I'm working on a chart I haven't done before. It usually involves me finding something similar here and then like looking at the example and this guy doesn't have the code on it. Hold on. And looking at the example and looking at the code below and seeing what the code's doing and learning from it. So that's how I would kind of go about next steps. We're at the end of time. I didn't make the end slide. Any questions or any departing thoughts? Questions?
I have a question.
Yeah.
So when do you like link to an external data file versus just having the data?
Yeah, you almost always want to link to an external data file, but for getting started and learning, I would just, like, if you can inline data, it makes it a lot easier to do that. But there are features, there are functions for loading data that D3 actually has, like d3.json or d3.csv. You can use those to load external files as well. In a production application, you're going to get your data from somewhere else. If you look in the D3 requests wiki, there's CSV, JSON, text, TSV, XML. There's some functions to help do that. But for getting started, I mean, it's very easy to just inline data if you want to play around.
Would you recommend going with the JS? Like, is that the vehicle of starting?
No, I think if you read that Lean Tips and Tricks book, it will give you some suggestions on how to set up a development environment. I'm pretty sure that's in there. You could start with JSBin for sure. It's just not, it's not great. The console is kind of whatever, and it's a little bit weird how you like save stuff over time. But you could. I mean, for me, this was like the quickest way to make examples for you guys that I could share. So you absolutely could do this. And what's nice about it is that like you basically just like click add library and select D3, and now you can write D3 in your JavaScript or whatever. I have it somewhere here. Yeah, D3.nest, etc. So that's probably the quickest way to just like start hacking with it. But you might want to check out that book and see what they say about setting up development environments and stuff like that. Any other questions? Cool. All right. Well, thank you guys.
Thank you.